geometry which we have, or else we can directly use FE which is generated by other preprocessor like hypermesh. Okay, so I'll just import here. Okay, now as you can see, this has a larger element size. Okay, now either I can remesh here itself and hypermesh, or I can take that to Ansys and remesh the geometry. Okay, so one and the same, you will get, no doubt, you will get fine image and fine mesh. With that, you can solve the problem very easily. So what I'll do, I'll just export in the same folder in windshield as bottle. So you can do analysis of bottle, or initially we do static and buckling for that, and further if you are interested, you can solve that for that problem for drop test also. Like what happens if that bottle is fallen from certain height, or what we call as impact test also. Okay, so that is one advantage of this problem. That is for your typically in aerospace we check for that impact test, or bird impact, or on the wind blade or your engine blades. Okay, so that is also one of a typical or critical problem. Now here I'll import as a mesh as an Astron deck. So I'll take as a bottle. So now this is not here. Sorry. It is on the other folder, right? And even we can try that also. This is the one, and one more is I'll just take a raw which is already a coarse mesh. Okay, with that we'll take a geometry also. So here we'll go for Astron again. I'm just showing you guys a number of options which will be helpful for you guys in future. Yeah, so now you can see your geometry is, or your mesh has been updated. I'll go with this for model first, model analysis. Similarly for here also, in the previous one the same thing. And first initially I'll go for model analysis. This model analysis, now you update it. Your model need to be updated here. Yeah, now this updated is again a link to static structure. That modal analysis is again linked to buckling analysis, and again give a update to project. Similarly I'll do here also. Then again link to buckling analysis, update project. Now here everything is updated. I'll right click and edit onto mechanical editor. As you know, we have only imported the FE element or FE mesh from both the geometry. As you can see, this geometry has two surfaces. Yes, surface 1 and surface 2. Okay, so if I check this for free, because as you see, the mesh is already updated. Yes or no? The mesh is updated already with the central line and the nodes are connected each other. So I want to ensure whether this mesh is connected entirely, and which will give us only again you need to surface. The problem is the surface thickness or your mesh thickness, because it is a 2D mesh, so your surface thickness also will matter. So I have given 25 mm and I'll solve for this to check whether each loading condition or each of that has a same. Now the other one, and just import, later will come there. As you can see, as the number of elements has been increased, your runtime also has been increased. Sorry for this again. I need to increase the mode shapes. Sorry. As you can see, your runtime is increasing for the same. Now, as you see, your mesh size and your geometry is different here. Why? Because your Ansys will create your surfaces based on your mesh size. As you see the mesh, which is coarse here, whereas in the previous, your mesh has been fine here. Yes, you understood what is the difference here and there? So that's what I have been making this as two imported geometry. Now, as we know that we are checking for modal analysis, you can see the seventh mode is positive value you are getting. That means I'll create the mode shapes. Sorry, select all the mode shapes. Sorry. So you can see that first 6 will be having 0 values, and the 7th will have a 7 mode shape will be having a positive value, which you can visualize here. Whereas in the previous, I'll show as first one. Until bottle has been rotating, or I'll increase your scale, you can visualize. Okay. So similarly, if we do a static, insert, fix support, insert, pressure, even with the force. So fixed support, I'll consider the base which will be kept on any floor or table or anything. Pressure, I'll apply inside from the inner surface. Okay. Or component or the surface to only normal to the surface, but I'll give a negative value for that. So I'll consider only -5 in the sense your pressure will be applied from the inner bottle. Okay, so that is what we require. Okay, the inner surface or inner fluid has it. Either you can use your static pressure, sorry, your liquid pressure for the self weight, or some external forces acting on the water bottle, that is from the top surface in the down direction. So we consider that with the vector, or you can go for component here. Component in the sense your z direction. So I'll apply around -100 or something, 100 Newton. Okay, just like 10 kg. That cannot be that. So I'll just take -10. So 1 kg or something on a bottle. So the required displacement will be, sorry, required output will be the displacement, strain, and stresses. Solve it. Okay. Now you can see. Now you can see your displacement. The true scale would be better. Yeah, the displacement value and the stresses. Okay. For that, for this, you can even change your force to 20, -20, so that you can see really what exactly happening. So with this, you can also check for the buckling of your water bottle. Like there are local buckling would be occurred. So you need to check which would be the most critical one. Okay. And in this, there was only one step. We are applying a load. In the sense, you're selecting a pressure for one shot, in one shot, because your surface are smooth because of your fine mesh. Okay, now I'll increase the buckling mode. I'll just show you. Yes, now you can see for your buckling mode shapes, which are already negative value. In the sense, for this, your buckling, when your load is reversed, the buckling occurs. You understand the negative value in the sense. Or you can even increase your buckling shapes to around 15 or 20, where you get in which mode you get more buckling critical. So you can even check for that. So this is one thing. The next, which we were discussing, when the mesh size is too coarse. So now the surface is different here.
Excuse me, sir.
Yeah,
Sir, we get a load multiplier value, no, sir, in the
yeah,
previous thing. We have to multiply that load multiplier with load or pressure, sir, in order to get a critical thing.
both.
We have to multiply with the both factors.
Both, yes, both. This load multiplier should be multiplied with the both the forces, because the effect is, or the value what you calculated, the software will be calculating that value will be of your combined effect. Okay,
Okay, sir.
so that is what the difference is. You need to multiply that for both the forces, not for individual. So
Excuse
this
me,
is
sir.
what. Yeah.
So what does the negative sign indicate?
Negative sign in the sense, your buckling will not occur for this direction of load. But if this load, whatever you're applying your force or pressure, okay, is being reversed, in the sense, if I apply this 50 as a positive, considering this, when I'll show you, when this force, whatever the pressure force, is applied as negative, that is from the inner side, the structure is not buckling. If the same pressure is applied from the opposite direction, that is from the outer, then there is a chance of buckling for this load. That is what the indication of the negative sign. Got it?
As long as the pressure is applied from the inner surface, buckling will not take place, sir.
No, for this, yeah, that's what I'm saying. For this, whatever your applied load, now till here, I've checked for 20, I'm not getting any positive value. So that means your structure is safe till certain thing when you are applying a pressure from the inner side. The same pressure, if I take this pressure as positive, okay, now we can check the same thing. You can, you will come to know 6 or 7, will come to know, like, the structure may fail for, or the load multi,
First,
sorry,
static structure solution, sir. First.
oh, okay, oh, the pressure itself has been changed, right? One second, let this, oh, yeah, it will take the previous value itself, not the negative value what we changed. Okay, it has been solved both. Okay, sometimes what happens, either of the load is like pressure or your what we call that point load, if that both the changes, then your structure might fail. That's what the meaning of the negative sign. Yes, now you can see the positive value. You're getting the point. Now you can say that same pressure when it is applied from reverse direction. So if I multiply this value to both pressure value as well as your force, you will get a, then our force is minus 20. So into 20. So you'll get this value. I'll just copy and paste here and the negative sign. Yes, this is the one. And the same scenario for the pressure also. For the pressure force, it is 50 positive. So this will be your pressure force to get this structure buckled in the sense. And I'll give the solution here itself. Both will have solve. In the sense, for the surface which we have given as 25 mm, you can think what 25 mm exactly, 2.5 centimeter. Okay, so for that thickness, your structure is taking this much load. As that, you can design lower as the load is required for by checking the buckling and static strength of both when the materials change. But this material is, we are considering structure steel, like a tin bottle or your water bottle, the thick steel water bottles. Okay, those kind of things. But the same thing here, only the changes, your element size is different. You can solve applying these boundary conditions, other things we can solve. Let us check here with the solution.
So when you give solve for eigen buckling, it will solve for the previous.
Both, yeah, both.
Okay.
Static structure as well as this thing, because static will not have any result. No, so now you can see the value as 1. So for that loading, when your pressure is from the outside, then the buckling occurs. Okay, that is what the meaning of the negative sign. Getting the point? So any doubt here?
So,
Yeah.
so for the positive pressure means the pressure exerted from the inside, is it?
No, from the outside. For this pressure, as you are seeing here, the direction is from outside.
Okay, sir. Okay, sir.
Okay. So negative in the sense the surface to the normal. So when you create your surface, or your surface is not created, it is generated by Ansys. So it takes as normal to your outer as a normal surface. Okay. So that is what the thickness definition of your thing. Either you can take this as top or end, then again it changes. Okay, mid behavior you can change here, then the entire thing of the geometry changes when you apply the loads or other things. Okay, so that is what the meaning of that. Yes, so for the same thing, as you can see with the coarse mesh, what we have done here, like changing the mesh size and we have kept it. Yes. So for this mesh or coarse mesh, as you can see, the coarse mesh is like, or typically each node has 10, that is 10 centimeter. We changed it to 1 centimeter for each. So for that, this generated surface or the generated surface has each different at different 10 mm. Okay. So now similarly, if I want to apply the pressure for the same structure, pressure. So what I need to do is like, I need to select all the surfaces. Yes, whereas in the previous you did it in one shot because the surface was very smooth. Now you can see all the surface. You can get the same result, no doubt in that. Only slight in a decimal or 2 to 3, 5% variation might be there because your element size changes. But the other things will have the same thing. What I'll do, I'll take this as a name selection as load. Okay, now whenever we want this surface, entire things, we can use them. Similarly, I'll apply a boundary condition with the other, giving a name selection. Now these two are there. For free check, it is not required, but for fixed, I'll check. So I'll take this as geometry selection to name selection, and that to load and boundary. I require boundary, and the other things you know that. So I'll take a total deformation and I'll take 7 modes, solve it. The solution is within a quick, but again, sorry, it is giving an error because the surface thickness is not given here. So I'll update to 25 mm again. Now I'll solve this problem. The solving time is less here compared to the previous problem because you can see, because your element size are less. So now you can evaluate, you can find your frequencies. This is the model analysis. When it comes to static structure, I'll apply pressure, I'll apply boundary condition also with the same load. So for pressure, okay, pressure is already there. So for pressure, I'll take the name selection again as a name selection load. And for fixed support, I'll take a name selection and apply for boundary. And for the force, I'll just select the edge, top edge, each individually again. But as you can see, yes. So then select the load. Now for the pressure value, I'll just take 50 as a positive only to the normal to the surface. As you know that if I apply inner, you will get a negative buckling. You will not get a positive value. So for that, I'm just considering it. Okay. So force, again I'll select component that will be negative Z. So I'll apply, just apply 100 Newton. So or just 50. In the previous we were applying 20, right? So 20 Newton in the sense 2 kg. And then apply output required. And then similarly analysis setting for buckling. I check, just take 6 and insert total deformation, and I will solve for this. Now the solution is faster than the previous model because the element size is larger, so number of equations will be very less. Yeah. Now you can see in the previous you were seeing how much was the load multiplier, 430. Now you see the load multiplier is 425. So this is a difference. Or else you can check with the displacement. Previously it was 0.009. Now it is 0.008.